So we have now used the half reaction method to balance in an acidic solution. And in this episode or this video, I wanted to show you how you can balance in a basic solution. You see, it's important to recognize when you're dealing with an acidic solution, first of all, because it's a solution, we know that it has extra H2O floating around. If it's an acidic solution, it means there's excess H+. But if you're dealing with a basic solution, there is no excess H+ in order to react, but there is excess OH-. And this is going to be the key to what we work with as we start balancing in a base. Now, as we balance in a base, it is pretty much exactly the same process as when we balanced in an acid, except for one major step. So let's just dive into our steps, and let's balance this reaction. So number one, we need to assign oxidation numbers. Pretty easy if you look at this reaction. Pure element, 0. Ion, +2. Pure element, 0. Oxygen, -2. Silver has to be +1 then. So what's actually changing here? Well, the silver is going from 0 to +1. That's going to be oxidation as it loses 1 electron. The zinc, on the other hand, is going from +2 to 0. It has to be gaining 2 electrons, and it's being reduced. So now that we've assigned our oxidation numbers, we can move on to our next step, and we can split this into 2 separate half reactions. So we're going to have our zinc reduction reaction happening on this side, Zn2+ turning into Zn, and then we're going to have silver turning into Ag2O on this side, our oxidation reaction. Simple enough so far. We've got our redox, or our 2 half reactions set up for our redox reaction. Step 3, same as before, balance mass. So 1 Zn, 1 in Zn, no oxygens, no hydrogens, balanced. 1 Ag, 2 Ags. We need a 2 there to balance that. 1 O, no O's. So we need to balance O's by adding water. So we have 1 oxygen, we need to add 1 H2O. And then we've added H's. So we're going to balance those H's by adding H+. Now, I'm just going to do something here. I'm going to move this zinc down because, to be honest, I'm going to need a lot of space for this one. So let's just get this out of the way. It's a pretty short one to balance anyway. Okay, here's our issue though, H+. That's for an acid. In a base, there's no excess H+, there's only OH-. So this is our new additional step. In a basic solution, we're going to add OH on each side of the balanced equation to offset all of the H+ that was added. And then we're going to combine the H+ and the OH-, and it's going to turn into water. So what does that look like? Well, I have 2 H+ here. So on the opposite side of the equation, I'm going to add 2 OH's. And if I do it on one side, I need to do it on the other. 2 OH's to keep everything balanced and equal, kind of like in math. Here's the thing though, when you have H+ and OH-, those will react with each other, and they are going to produce H2O. So instead of having H+ and OH-, we now have H2O. So I'm going to rewrite this new equation with what we have now. We have 2 OH- plus H2O plus 2 Ag. That's going to make Ag2O plus 2 H2O. Now you may also notice I have an H2O here and 2 H2Os here. There's really no point in writing them on both sides. So we can now modify this equation one more time and eliminate the H2Os on one side and just have our equation looking like that. Oh, don't forget your minus sign. So at this point, I now have the masses of these equations balanced. I have OH's offsetting my H pluses. I have H2O's to balance any excess things that were happening. I now have balanced equations, except when it comes to charge. So we need to balance the charge by adding electrons. So if we count up our charge on each side, here we have two minus as our overall charge. The 2 from the OH gives us that minus 2. Overall charge is 0 over here. What that means is we're going to be adding 2 electrons on this side of the equation. Here we have an overall charge of positive 2 and an overall charge of 0. So we need to add 2 electrons in this equation. So now that we've done that, we need to make sure that we have equal amounts of electrons in both reactions. And we actually do. We have 2 electrons. So we do not need to multiply like we did in previous reactions. But now we need to add our 2 half reactions together. So I'm going to start with this one. Remember, we're going to stack our 2 equations on top of each other. So we're going to have 2 OH minus plus 2 Ag, producing Ag2O plus H2O and 2 electrons. Here we're going to have 2 electrons and Zn2 plus, turning into Zn. Now, you notice there's no OHs to cross out, there's no H2Os to cross out. We just have those electrons that we need to cancel. And now everything on the left-hand side of the arrow is going to come down together. So 2OH plus 2Ag plus Zn2 plus, turning into Ag2O plus zinc plus H2O. We now have 2 O's, 2 O's, 2 H's, 2 H's, 1 zinc, 2 Ag's, 2 Ag's. The other thing that's totally balanced here is the overall charges. Minus 2 and positive 2. It's an overall charge of 0. Overall charge of 0. Everything is totally balanced, and we have balanced our redox reaction in a basic solution. So remember, in a basic solution, when you have OH minus. So when you add H plus, add an equal amount of OH to both sides. The H plus will react with the OH to make H2O and cancel any H2Os possible, and then continue your balancing with electrons. That's the only difference when working in a basic solution, and yeah, it's a little bit more work, but that is how we balance in a basic solution. So thanks for watching, and I'll see you next time.